let's see if we can tackle a slightly more difficult hyperbola graphing problem. So let's say I have the hyperbola, make this up on the fly, x minus 1 squared over 16 minus y plus 1 squared over, let's say, 4 is equal to 1. So the first thing to recognize is that this is a hyperbola, and we'll, in a few videos, do a bunch of problems where the first point is just to identify what type of conic section we have, and then the second step is to actually graph the conic section. So here, I already told you that we're going to be doing a hyperbola problem, so you know it's a hyperbola. But the way to recognize that is you have this minus of the y squared term, and then we actually have it shifted, right? The classic or the standard non-shifted form of a hyperbola, or a hyperbola centered at 0, would look something like this, especially if it has, I guess, the same asymptotes, just shifted but centered at 0. It would look like this: x squared over 16 minus y squared over 4 is equal to 1. And the difference between this hyperbola and this hyperbola, the center of this hyperbola is at, let's see, the center is at the point x is equal to 1, y is equal to minus 1. And the way to think about it is x equals 1 makes this whole term 0, and so that's why it's the center. And y equal to minus 1 makes this whole term 0. And on here, of course, the center is the origin. Center is 0, 0. So the easy way to graph this is to really graph this one, but you shift it so you use the center being 1 minus 1 instead of the center being 0, 0. So let's do that. So let's figure out the slope of the two asymptotes here, and then we can shift those two slopes so that it's appropriate for this hyperbola right here. So if we go with this one, let's just solve for y. That's what I always like to do whenever I'm graphing a hyperbola. So we get, let's see, minus y squared over 4, subtracting x squared over 16 from both sides, minus x squared over 16 plus 1. I'm working on this hyperbola right here, not this one. And then I'm just going to shift it later. And then let's say multiply both sides by minus 4, and you get y squared is equal to, see, the minus cancels out with that, and then 4 over 16 is x squared over 4 minus 4. And so y is equal to plus or minus square root of x squared over 4 minus 4. And to figure out the asymptotes, you just have to think about, well, what happens as x approaches positive or negative infinity? As x gets really positive or x gets really negative? And we've done this a bunch of times already. And I think this is important. This is more important than just memorizing the formula, because it gives you an intuition of where those equations for the lines of the asymptote actually come from. Because these are what this graph or this equation or this function approaches as x approaches positive or negative infinity. So as x approaches positive or negative infinity, as x approaches positive and negative infinity, what is y approximately equal to in this case? Well, once again, this term is going to dominate. This is just a 4 right here. You could imagine when x is like a trillion or a negative trillion, this is going to be a huge number. And this is going to be just like, you can almost use like round off error. You take the square root of that. And so this is going to dominate. So as you approach positive or negative infinity, y is going to be approximately equal to the square root, the positive and negative square root of x squared over 4, so y would be approximately equal to positive or negative, what's the square root of this? X over 2, or 1/2 x. So let's do that. So let's draw our asymptotes. And remember, these are the asymptotes for this situation. But now, of course, we're centered at 1, negative 1. So I'm going to draw two lines with these slopes, with positive 1/2 and negative 1/2 slopes. But they're going to be centered at this point. Because I just got rid of the shift just so I could figure out the asymptotes. But of course, this is the real thing that we're trying to graph. So let me do that. Let's see, so this is my x-axis, my y-axis, sorry. This is my x-axis. And the center of this is at 1, negative 1. 1, negative 1. So x is equal to 1. Y is equal to minus 1. Fair enough. And then the slopes of the asymptotes were positive and negative 1/2, right? Positive and negative 1/2. So let's do the positive 1/2. So that means for every 2 you run over, so if you go positive in the positive x direction 2, you move up 1. So you go to the right 2 and up 1. So that's the first one. And let me draw that asymptote. Yeah, it looks something like that. And then let me draw it from this point to that point. Oh, gotta have a steady hand. Okay, there you go. I think you get the point. And then the other asymptote is going to have a minus 1/2 slope. So if I remember, this is our center, 1 minus 1. So if I go down 1 and over, so when I go over 2, I go down 1. So that'll be right there. Let me draw those asymptotes, or that asymptote. It's going to look like that. And then just to continue it in the other direction, it's going to look, well, then I want to make it, the lines overlap. It's going to look something like that. So we've drawn our asymptotes for this function, and now we have to figure out if it's going to be a kind of a vertical hyperbola or a horizontal hyperbola. And the easy way to think about it is to try to make, and we can do it two ways. I mean, if you just look at this equation right here, when you're taking the positive square root, we're always going to be slightly below the asymptote, right? The asymptote is this thing, but we're always going to be slightly below it. So that tells us that we're always going to be slightly below the asymptote on the positive square root. And we're always going to be slightly above the asymptote on the negative square root, because it's going to be a little less and it's negative. But I'll let you think about that. So I already tell you, my intuition is going to be there and there. It's more than intuition. I know that we're going to be a little bit less than the negative square root. But I'll do it the other way. I'll do it the way I did in the last video. So the other way to think about it is, what happens when this term is 0? For this term to be 0, x has to be equal to 1. And does that ever happen? Can x be equal to 1? If x is equal to 1 here, this term is 0. And then you have a situation where, let's see, if x is equal to 1, this is 0. And then you have a minus y squared over 4 would have to equal 1, or this would have to be a negative number. So x could not be equal to 1. So y could be equal to negative 1. Let's try that out. If y is equal to negative 1, let's try out that point. If y is equal to negative 1, this term right here disappears, right? When y is equal to negative 1. You negative 1 plus 1, that's 0, 0, 4. So when y is equal to negative 1, you're just left with, I'll do it down here. Well, I don't want to, you're left with x minus 1 squared over 16 is equal to 1. Right? I just canceled out this term because I'm saying what happens when y is equal to negative 1. You multiply both sides by 16, you get, let me do it over here. These get messy. X minus 1 squared is equal to 16. Take the square root of both sides. X minus 1 is equal to positive or negative 4. And so if x is equal to positive 4, if you add 1 to that, x would be equal to 5, right? And then if x minus 1 would be minus 4, and you add 1 to that, you would have x is equal to 3. So our 2 points, I guess you can kind of view our 2 points closest to our center are the points 5, comma, negative 1, and 3, comma, negative 1. And let's plot those two. So 5, 1, 2, 3, 4, 5, negative 1, and 3, negative 1. Is that right? So, oh, no, minus 3. So because x minus 1 could be minus 4. That's what happens when you skip steps. And if you have minus 1 plus, let me write that. So x minus 1 is either equal to 4, or x minus 1 is equal to minus 4. If you have the minus 4 situation, then x is equal to minus 3. So you go 1, 2, 3, minus 3, minus 1. So those are both points on this hyperbola. And then our intuition was correct, or at least what I said, that we're always going to be below the positive square root is always going to be slightly below the asymptote. So we get our curve is going to look something like this. It's going to get closer and closer, and then here it's going to get closer and closer in that direction. It keeps getting closer and closer to that asymptote. And here it's going to keep getting closer and closer to the asymptote on that side, and then on that side. And of course, these asymptotes keep going on forever and forever. And if you want, you could try out some other points just to confirm. You could plot that point there or that point there just to confirm that that's the case. The hard part really is just to identify the asymptotes and just to figure out, do we sit kind of on the left and the right, or do we sit on the top and the bottom? And then you're done. You can graph your hyperbola. See you in the next video.